Hello students, welcome back. In the last video I've explained you that 1 is neither a prime nor a composite number. So 1 is neither prime nor a composite number. Rather it's a unique number. Okay, because 1 has only one factor. So that's why 1 is a unique number. Let us see now in this video what about all these natural numbers from 2 to 10. Are these natural numbers prime or composite? Okay, so let's begin with 2. So as I told you, to find the number whether it's a prime or composite, first of all you have to start dividing these numbers by some divisors. So the first divisor for all this natural number will be 1, and the last divisor for all this number would be the number itself. That means for 2 it will be 2, and in between, after you write 1 and the number itself, whatever natural number comes in between, you write those numbers also. But you know that after 1 it just comes the 2, so it means we don't have any number in between. So let's divide this 2 by these two divisors, the number by which you divide. 1 2 is 2, remainder 0. So you can find that 1 is a factor because 2 is divisible completely by 1. That means remainder 0. So yes, 1 is a factor. Now let's divide the same natural number 2 by the second divisor 2. 2 1 is 2, remainder comes here also 0. That means yes, this natural number 2 has exactly two factors, that is 1 and the number itself. And we all know a prime number is a natural number which has exactly two factors, that is 1 and the number itself. That's why 2 is a prime number. In fact, from the list of natural numbers, 2 is the first prime number. Okay. Now let's see what about 3. Whether 3 is a prime or composite. So we'll do the same thing. We divide this 3 by the first divisor 1, and the last divisor will be the number itself. And you know, between 1 and 3 comes 2. That means now we'll divide this natural number 3 to know that whether 3 is a prime or composite. We divide this 3 by all this divisor. Let us divide. 1 3 is a 3, and you subtract, remainder comes 0. Since remainder is 0, then this 1 divides 3 completely. And let's divide this same number, natural number 3, by the second divisor 2. 2 1s are 2 because 2 2s are big. So subtract, so remainder 1. Since remainder is 0, since remainder is not 0, it means 2 cannot divide 3 completely. So 2 is not a factor of 3. And let's divide this 3 by the third divisor 3. 3 1s are 3. When you subtract, remainder comes 0. So you can see that 3 has exactly two factors. This 1 and the number itself. So this also confirms that 3 is also a prime number, because it has only two factors, just like 2. What about the next natural number, 4? Let's see. To find out whether 4 is a natural number or to find whether 4 is a composite number or prime number, we do same process. We divide this 4 by 1, and the last divisor will be the number itself. And between 1 and 4 comes 2 and 3. So let's divide this 4 by first 1. 1 4 is a 4, remainder comes 0. So yes, 1 is a factor. Let's divide this 4, now second divisor 2. 2 2s are 4. You can see clearly that in this case also remainder comes 0. So it means that 2 can divide 4 completely. So yes, 2 is also a factor of 4. I'm circling if it's factor and cancelling if it's not factor. Now let's divide 4 by the third divisor 3. 3 1s are 3, 3 2s are 6 big, so 3 1s are 3. Now subtract 4 minus 3, 1. So you can see that in this case the remainder is not 0. That means 3 is not a factor of 4. And finally we divide this 4 by this 4 given 4 natural number by the fourth divisor 4. You can see that 4 1 times 4, and subtract, and so yes, 4 is a factor. Now we can see that factors of 4 are what? What are the factors of 4? The factors of 4 are, in this case the factors of 4 are 1 2 and 4. So you can clearly see that this 4 has more than 2 factors, because there are 3 factors, so it means more than 2. And we all know that any natural number which has more than 2 factors, they are called composite number. That's why 4 is a composite number. Instead, the 4 is a composite number because 4 has more than 2 factors. The last video I've already explained you that 5 is a prime number because 5 you can divide only by two factors, this 1 and by itself, so 5 is a prime number. In the last video also I've shown you that 6 has more than two factors, so 6 is a composite number. 5 is a prime number. So in this way we can see that 7, when you do the same process, and 7 will have exactly two factors, so 7 is a prime number. Whereas 8 will have more than two factors. You'll find that if you do the same process like this, you can try it yourself. You suppose you want to find the factors of 8, you start with 1 and the last divisor will be the 8 itself, and you then divide all the numbers here which comes in between 1 and 8, and then you divide this natural number 8 by all these divisors and check for remainder. This is 1 8s are 8, so 1 is factor, 2 4s are 8. You can just remember the table also. If this 8 is a multiple of 2, then it's a factor. If this 8 is not a multiple of any particular number, then it's not a factor. Like in the table of 3, 8 don't come, so 8 is not a multiple of 3. 4 1s are 4, 4 2s are 8. Yes, 8 is a multiple of 4. 5 1s are 5, 5 2s are 10. 8 don't come. 6 1s are 6, 6 2s are 12. So 8 don't come in the table of 6. 7 1s are 7, 7 2s are 14. So 8 don't come. 8 1s are 8. So you can see that 8 has how many factors? 1, 2, 3, 4. There are 4 factors of 8. So any natural number which has more than two factors, they are called composite number. That's why 8 is a composite number. These are all composite numbers. So 9 also comes out to be composite number, 10 also comes to be composite number. In this way, if you keep on trying, so in this way you can just find out any number where there's any natural number where there's a prime or composite number. So I hope you have understood now how to identify prime number and composite numbers. So in short, let me now tell you. So after this discussion, how to identify natural numbers are prime and composite numbers, after having finished giving you the idea how to find out whether natural number is a prime number or composite number, now let me tell you all the prime numbers from 1 to 100, because these prime numbers are absolutely needed for the next exercise. Okay, so as you can see that 2 is the first prime number in the list of natural numbers, and let me tell you one thing, 2 is also an even natural number. So 2 is the only even natural number which is also a prime number. That means there's actually two factors. And after 2 we have next prime number is 3, the next prime number is 5, then 7, then I've not shown you after 11, after 10, but then if you do the same process, you'll find that the next prime number is 11, then next 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and last but not the least, it's 97. Please don't get confused. I'm saying it's the last number because I'm writing prime numbers only from 1 to 100. So within 100, that's the last prime number before 100. Then the list of prime numbers doesn't end because we have more numbers after 97 also. Because since natural numbers has no end, so the prime numbers also have no end. But at least you have to buy out these prime numbers from 1 to 100. So then which are the composite numbers? Obviously, if I have to tell you about composite numbers from 1 to 100, then very easy. You just ignore 1, exclude 1 because 1 is neither prime nor composite, and exclude all these numbers from 1 to 100. And all the remaining numbers are composite number. Example like 4. So 4 is the first composite natural number. Then comes 6, then 8, 9, 10, and here 12, then 14, 15, 16 are composite number. In this way, whatever numbers are missing here in the list of prime, all the numbers are composite numbers. Remaining all numbers are composite. So at least you have to memorize this. Please memorize, okay, all this. So we are now ready to start the next exercise. Thank you so much.